The most important line in the history of human civilization is a line that does not exist. It is invisible. It has no political border, and it has killed more people than any war. We are taught to take it for granted, a thin, arbitrary convention known as the Prime Meridian. But its placement was not arbitrary. It was a battlefield, a fight over measurement that was really a fight over global power, cultural dominance, and the right to define reality itself. For centuries, every major empire insisted on its own zero-degree reference point. To use their line was to admit they controlled the world's clock, its navigation, and its future trade. This rivalry reached a breaking point in 1884 when representatives from 26 nations met in Washington, D.C. to end the conflict. But the true fight wasn't about where the line should go. It was about why the line was needed at all, and what would happen to a culture that lost the right to draw it. To understand the violence of the 1884 decision, one must first confront the terrifying abstractness of the problem it solved. We live today in a world where location is a trivial certainty. We glance at a glowing screen and see a blue dot placed precisely within a grid of streets. We have forgotten that for the vast majority of human history, location was not a fact, but a desperate hypothesis. The fundamental architecture of the planet offers us two axes, but they are not created equal. Latitude, our distance north or south, is written into the physical laws of the universe. It is dictated by the sun and the stars. A navigator in 300 BC, standing on the deck of a wooden trireme, could look at the height of the Polaris star above the horizon and know with reasonable certainty how far he was from the equator. Nature provided the ruler. Longitude, our distance east or west, is different. Nature provides no ruler for it. The Earth spins. The stars that are overhead in Athens at midnight are overhead in Gibraltar an hour later. East and west are not static places. They are functions of time. To know where you are on the horizontal axis of the world, you must know what time it is where you stand, and simultaneously, what time it is at a 0 point somewhere else. This requirement, the simultaneous knowledge of two different times, was the impossible wall against which thousands of ships were smashed. For centuries, this was the Longitude Problem. It was not merely a mathematical puzzle, it was the abyss of the ancient world. Without a reliable way to measure east and west, a ship out of sight of land was effectively lost in a gray void. They relied on dead reckoning, a method of estimation so prone to error that it was colloquially known as guessing. The first civilization to attempt to impose order on this chaos was, inevitably, the Greeks. In the 2nd century AD, the polymath Claudius Ptolemy composed the Geographia. This was not simply a book. It was the source code for Western cartography. Ptolemy understood that to map the world, one needed a vertical line from which all other measurements would flow. He did not choose Rome or Alexandria or Athens. He chose the absolute edge of the known universe. Ptolemy placed the first Prime Meridian at the Fortunate Islands, now the Canary Islands. In the ancient mind, this was the end of the world. Beyond these islands lay the Oceanus, the unnavigable endless water. By placing the zero line at the westernmost edge of reality, Ptolemy ensured that all coordinates in the known world would be positive numbers counted eastward from the edge. It was a decision of elegant philosophical beauty. It stated that the world begins at the edge of the unknown. But as the centuries ground on, and the Roman Empire collapsed into the fractured feudalism of the Middle Ages, Ptolemy's line faded from a scientific standard into a vague memory. The concept of a unified world time vanished. In its place, the world fractured into local solar times. Every monastery, every village, and every walled city operated on its own clock, set daily by the local noon. When the sun was highest over the cathedral spire in Chartres, it was noon in Chartres. 100 miles to the east, it was already 12:15. This localized reality worked for a peasant whose world ended at the horizon. It did not work for an empire that sought to span the ocean. By the dawn of the age of exploration in the 15th century, the lack of a prime meridian had transformed from a philosophical curiosity into a crisis of blood and treasure. As European powers began to push heavy, cannon-laden carracks into the Atlantic, they entered the graveyard of navigation. Without a zero line, captains kept their own logs relative to their last known port. A Portuguese captain might measure his longitude from Lisbon, a Dutch captain from Amsterdam. If they met in the mid-Atlantic, they literally could not agree on where they were. They existed in two different mathematical realities. Maps became guarded state secrets, filled with deliberate errors to mislead competitors. Islands were discovered in one location, charted, and then never found again because the longitude was miscalculated by 300 miles. The ocean became a space of pure uncertainty. To sail west was to gamble that your math was better than the wind. It was in this chaotic vacuum that the first great meridian wars began to take shape. The powerful monarchs of Europe realized that whoever could define the zero line, whoever could place the invisible anchor, would not just map the world, they would own the trade routes that crossed it. The first true salvo in the Meridian Wars was not fired by a cannon, but by a quill pen in the Vatican. In 1493, 1 year after Columbus stumbled upon the Americas, the powers of Europe realized the world was larger and more profitable than they had imagined. Spain and Portugal, the two maritime superpowers of the age, immediately fell into a dispute over who owned the New World. To prevent a war that would consume Christendom, Pope Alexander VI intervened. In 1494, the Treaty of Tordesillas was signed. This was the most audacious act of cartography in human history. The Pope drew a single vertical line of longitude 370 leagues west of the Cape Verde Islands. He decreed a simple, brutal binary. Everything discovered to the east of the line belonged to Portugal. Everything to the west belonged to Spain. This was the Tordesillas Meridian. It was the first attempt to use a line of longitude as a geopolitical weapon. It shaped the modern world. It is the reason Brazil speaks Portuguese while the rest of South America speaks Spanish. But there was a fatal flaw in this divine decree. No one knew where the line actually was. The Pope had drawn a line on a parchment map, but on the heaving gray Atlantic, the line was invisible. Spanish and Portuguese captains argued violently over its location. They pushed the line back and forth to claim spice islands and gold mines. The Tordesillas line proved that a meridian could define the law, but without precise measurement, the law was a fiction. The world needed more than a decree, it needed a science. As the 17th century dawned, the center of gravity shifted north. The mystical authority of the Pope was replaced by the cold, rational ambition of the Enlightenment. The new powers, France and England, did not want a line based on theology. They wanted a line based on astronomy. France, under the Sun King Louis XIV, took the lead. For the French, the meridian was an intellectual project, a symbol of the supremacy of French reason. In 1666, Louis XIV founded the Académie des Sciences and ordered the construction of the Paris Observatory. The observatory was not just a building, it was a machine for measuring the universe. Its architect, Claude Perrault, designed the building so that it was perfectly bisected by the north-south line. This was the birth of the Paris Meridian. A brass line was inlaid across the floor of the Cassini room, a physical manifestation of French zero. Under the leadership of the Italian-born astronomer Giovanni Domenico Cassini, the French treated the meridian as a tool for mapping the land. They turned their telescopes inward, mapping the Kingdom of France with a precision never before seen. They discovered, to the king's horror, that France was actually smaller than previous crude maps had suggested. Louis XIV famously joked that he had lost more territory to his astronomers than to his enemies, but the result was the famous Cassini maps, the first accurate scientific triangulation of a nation-state. The Paris Meridian became the gold standard of scientific cartography. Across the Channel, the British were watching with deep insecurity. King Charles II, whose mistress was the French spy lady Louise de Querouaille, was acutely aware that France was outpacing England in the sciences. But England's needs were different. France was a continental land power. England was an island. France needed to map the land. England needed to survive the sea. In 1675, 9 years after the Paris Observatory, Charles II signed a royal warrant to establish the Royal Observatory at Greenwich. He appointed John Flamsteed as the first astronomer royal with a specific, desperate instruction: to find the so much desired longitude of places for the perfecting of the art of navigation. Note the distinction. Paris was built for science and mapping. Greenwich was built for navigation. It was a utilitarian project from day one. The Greenwich Observatory was built on a hill outside London, overlooking the River Thames, the artery of British trade. Every day, the astronomers could look down and see the sails of the merchant fleet leaving for the Indies, carrying the wealth of the empire into the dangerous void. This set the stage for the Great Divergence. For the next 200 years, the world would be split between two competing realities. If you looked at a French map, the world began in Paris. If you looked at a British map, the world began in London. The two nations began to race. They were not just racing to map the stars, they were racing to solve the Longitude Problem. The method that won would dictate the location of the Prime Meridian. The French astronomers bet on the lunar distance method. They believed that by measuring the precise distance between the moon and specific background stars and comparing that to a table of predicted positions calculated in Paris, a navigator could determine the time in Paris and thus his longitude. It was a method of pure, high-minded mathematics. It required a navigator to be a mathematician, to look up at the heavens and perform hours of complex calculations by candlelight on a rolling ship. The British, while also pursuing the lunar method, began to entertain a different, more mechanical possibility. What if the solution wasn't in the sky? What if the solution was in a box?
The Longitude Act of 1714 crystallized the greatest scientific bounty ever offered: £20,000 to anyone who could solve the problem of longitude with an error margin of less than half a degree. The competition immediately fractured into two hostile camps, reflecting the profound cultural difference between the British and French approaches. The astronomers. The establishment, led by the Astronomer Royal Neville Maskelyne, bet on the lunar distance method. They sought the solution in pure, elegant mathematics. They believed it was beneath the dignity of science to rely on a clock, an unreliable and messy mechanical device to solve a problem of celestial mechanics. The horologists, represented by one man, John Harrison, bet on the machine. Harrison was a self-taught carpenter from Yorkshire, an outsider to the academic world. He understood that the problem of the sea was not a problem of the stars, but a problem of friction, rust, and the physical violence of the ocean. His solution was not an equation, but a series of masterpieces in counter mechanics. Harrison's first major innovation, H1, was a massive, intricate cage of brass designed to compensate for the motion of the ship by using counterbalancing weights. It was a failure of portability, but a triumph of accuracy. It was his fourth model, the H4, that changed history. The H4 was small enough to fit in a large pocket. It was a watch, but its engineering was revolutionary. It used a bimetallic strip to compensate for temperature, allowing the clock to maintain its pace whether sailing in the freezing North Atlantic or the steaming Caribbean. More importantly, it used a specific type of detached escapement and diamond pivots to minimize friction, allowing it to keep time with an accuracy that was, at the time, miraculous. In 1761, Harrison's H4 underwent its definitive trial. It sailed from England to Jamaica. The official calculation using the established astronomical tables placed the ship's longitude at one position. The H4 predicted another. When the shore was finally sighted, the H4's prediction was correct within 5 seconds, an error of less than half a nautical mile. The longitude problem was definitively solved. Yet, the establishment refused to pay the price. The astronomical board, dominated by Maskelyne, believed that a solution derived from clockwork, a mere trade, could not be the true answer. They fought Harrison for years, demanding that he produce more copies, reveal his secrets, and prove his machine was not a fluke. Harrison eventually received the bulk of the prize only after personally appealing to King George III, who declared, "By God, Harrison, I will see you righted."
The victory of the Greenwich chronometer in the 18th century was only the naval solution. The ultimate standardization was forced by the revolutionary speed of the 19th century, specifically by the locomotive and the electric telegraph. As railway networks exploded across continents, the historical luxury of local mean time, where every town set its clock by its own solar noon, became a critical danger. Before standardization, a town in Ohio might be 3 minutes different from a town 5 miles down the tracks. In the era of stagecoaches, this was charming. In the era of high-speed rail, it was catastrophic. Timetables were impossible to synchronize. Trains ran on contradictory schedules, leading directly to collisions, delays, and a massive loss of industrial efficiency. The crisis peaked in the United States, where the sheer size of the continent made the problem absurd. By 1883, there were over 50 different local railway times across the American network. A passenger traveling from Maine to California would have to reset his watch nearly 24 times. The railroads themselves, not the government, finally took command. The General Time Convention of 1883, led by the railroad companies, decreed the creation of standard time zones for the continent.
They drew lines across the American map, carving the nation into 4 time zones: Eastern, Central, Mountain, and Pacific, each separated by exactly 1 hour. This was a direct, practical acknowledgement that solar time had to be sacrificed for industrial time. This new system was functional, but it created an immediate, profound question. Where should the 0 point for these synchronized time zones be located? The American railroadmen had adopted the Greenwich system for logistical ease, tying the entire new structure to the British 0. The scale of American industry had quietly validated the decision that Britain's Royal Navy had fought for a century before. The intolerable friction of the wire. The final straw was the electric telegraph. Communication was suddenly instantaneous, but the timestamps on those communications were contradictory. A message sent from Paris bearing a timestamp of 10 a.m. might arrive in London, where the local time was 9:05 a.m., but the official telegram time might be 9:35 a.m. due to internal, conflicting railroad standards. This intolerable friction proved that global trade and diplomacy could no longer withstand the existence of multiple zeros. The situation demanded an international agreement backed by the political will of every major power. The final resistance of the Paris Meridian. As the call for a consensus conference grew louder, France dug in her heels. The French position was complex. It was not purely about national pride, though that was a powerful factor. It was rooted in the metric system. They argued that their meridian, based on the calculation of the Earth's circumference, which defined the meter, was more fundamentally scientific and universal than the Greenwich line, which they derided as a line of arbitrary convenience enforced by naval power. France proposed a neutral meridian, perhaps one running through the mid-Atlantic or even the Bering Strait, a line that belonged to no major power and could thus be truly universal. But the other major powers, including Germany, Austria, Hungary, Russia, and the rising power of the United States, saw this as an attempt to stall the inevitable. They recognized that adopting a theoretical neutral line would require everyone to change all their nautical charts, train schedules, and astronomical tables, a colossal, paralyzing expense. Conversely, 72% of the world's shipping was already operating on the Greenwich line. The practical cost of changing was astronomical. The cost of not changing was simply diplomatic ego. The argument had boiled down to 2 choices. The rational choice, France, a scientifically superior metric-based line that would cost billions to implement. The practical choice, Britain/US/railroads, a line of established industrial convenience that required minimum change. In 1884, the President of the United States, Chester Arthur, issued the formal invitation to 26 nations to attend the International Meridian Conference in Washington, D.C. The objective was singular: to decide, once and for all, where the world should begin. The conference was designed not to debate the merits of the lines, but to confirm the victor that industry and commerce had already chosen. The final battle was about to take place not on the high seas, but in the quiet, mahogany-paneled conference rooms of the American capital.
The International Meridian Conference convened in Washington, D.C. in October 1884. 26 nations were represented, their delegates filling the State Department rooms with the collective weight of global sovereignty. The atmosphere was one of strained cordiality. This was less a scientific conference and more a diplomatic burial, a formality required to ratify a commercial reality. The key players knew the stakes. The conference had to select a single line of longitude to be the official prime meridian of the world. By extension, it would select the 0 point for all subsequent time zones and all future cartology. The power to define the world's clock was, effectively, the power to measure global civilization. The American delegation, led by Admiral C.R.P. Rogers, ensured the proceedings were structured for resolution, not endless debate. The delegates were first asked to agree on a few fundamental principles: that the meridian must be singular, that it must be used for both longitude and time, and that it must divide the world into two hemispheres of 180 degrees each. The procedural structure immediately narrowed the viable candidates. The debate came down to three primary lines: Greenwich, the line of established trade and naval power; Paris, the line of scientific purity and the metric system; and a neutral line, a theoretical zero such as the Azores, which would require the least national humiliation but the greatest logistical cost. The French delegation, led by Hippolyte Tassot, mounted the final, eloquent defense of the Paris Meridian. They argued that the choice of the Prime Meridian was a moral obligation to future generations, demanding a selection based on universal principles, not the temporary commercial advantage of a single nation. Tassot passionately urged the delegates to reject the accident of history that favored Greenwich and instead choose the Paris line, which was interwoven with the universal standard of the meter. The British delegation, led by Sir Frederick Evans, countered Tassot's philosophical plea with cold, irrefutable statistics. They pointed out that an estimated 72% of the world's ships and 90% of its commerce were already charting their courses using Greenwich. They argued that to select any other line, even a scientifically pure one, would create a massive, immediate financial disruption and a generation of cartographical chaos. They presented the Greenwich line not as the best choice, but as the least worst choice, the option of maximum efficiency and minimal cost. The United States, Germany, and Russia, all industrial powers demanding global coordination, stood with Britain. They understood that the metric system, while vital, was not worth the cost of scrapping every railroad timetable and naval chart on Earth. The argument for pragmatism won out over the argument for idealism. The final vote was taken on the proposal that the conference proposes to the governments here represented the adoption of the meridian passing through the center of the transit instrument at the Observatory of Greenwich as the initial meridian for longitude. The results were decisive. For Greenwich, 22 nations, including the US, Germany, Russia, Italy, and Britain. Against Greenwich, 1 nation, Santo Domingo. Abstaining, 2 nations, France and Brazil. The resolution was passed. The invisible line, once a vague boundary on a parchment map, became codified international law. The world's clock was officially reset, and the 0-degree mark, the beginning of global time, was permanently established not by celestial observation or metric purity, but by the relentless, practical force of Victorian naval and industrial power.
The passage of the resolution on October 13, 1884, did not bring about universal acceptance. It brought about universal compliance, which is a very different thing. The vote immediately fractured the global community into 3 distinct groups: the pragmatists, the purists, and the defiant. The pragmatists, led by Britain and the United States, immediately began the work of standardizing their charts and railroads, validating the choice through rapid industrial implementation. The purists, like the delegates from Germany and Austria-Hungary, accepted the Greenwich line despite having a history of using their own national meridians. They understood that the metric ideal was less critical than the need to synchronize the massive machinery of their respective empires. The defiant were France and Santo Domingo. Santo Domingo's single dissenting vote was a powerful, if small, protest against the geopolitical bullying of the major powers. Their vote was a defense of their own right to define their national space, refusing to assent to a system imposed by distant, colossal empires. France's abstention was far more significant. The French refused to surrender the intellectual prestige of the Paris Meridian. For decades following the conference, France maintained the Paris line as its national reference. Navigators who needed to be compatible with global charts used the Greenwich conversion, but officially the nation operated on its own time. France only officially adopted Greenwich time in 1911, and even then, they did it with a subtle final act of defiance. The law did not mention Greenwich Mean Time, but instead referred to Paris Mean Time, retarded by 9 minutes and 21 seconds. This was the exact calculated difference between the two observatories. They accepted the clock, but refused to utter the name of the rival city. The Great Surrender, from solar time to industrial time. The most profound consequence of the 1884 vote was the immediate birth of the global time zone system. Before 1884, time was a local phenomenon. Every city, every village used local mean time, calculated precisely when the sun crossed the meridian overhead. This anchored human experience to solar reality. The Prime Meridian, anchored now in Greenwich, annihilated this system. To maintain the efficiency of the new industrial world, the world was carved into 24 distinct time zones, each centered on a line of longitude separated by 15 degrees, since 360 degrees over 24 hours equals 15 degrees. This standardization required a collective, global surrender of the local consciousness. People were forced to accept that the time on their clock was no longer dictated by the sun's position, but by the clock in a distant foreign observatory. Philosophically, this was the beginning of the globalized mind. The line forced billions of people to coordinate their existence with an abstract, imposed logic. The farmer in the American Midwest, the railway conductor in Russia, and the merchant in Shanghai were all suddenly slaves to the synchronization required by trade and industry, forced to live by a time that was, locally, incorrect. The price of this global coherence was the loss of local geographical authenticity. The Prime Meridian did not just straighten out maps, it straightened out human behavior, laying the foundation for the rapid, coordinated, and often dehumanizing speed of the 20th century. The system worked perfectly, but it created an environment where the unique cultural art of self-defined time was lost forever.
The final, ironic chapter of the Prime Meridian is its disappearance. For a century after the 1884 vote, the line remained a potent physical reality, anchored to the brass strip at the Royal Observatory in Greenwich. Millions of tourists stood with one foot in the east and one foot in the west, marking the physical reality of the political decision. But the 20th century rendered this physical marker obsolete. The line was forced to become an abstraction once more, driven by a new technological imperative: satellite navigation. The Earth is not a perfect sphere, and it is not static. Continents shift, and the planet wobbles on its axis. When the Greenwich line was chosen in 1884, it was based on the celestial zenith of the observatory's transit telescope. However, when engineers began to develop the Global Positioning System, GPS, they needed a far more accurate and stable reference point. A zero line, anchored not to a shifting building, but to the calculated geometric center of the entire Earth's mass. The modern meridian, the one that governs your phone, your navigation, and your global trade, is called the International Reference Meridian, IRM. It is part of the International Terrestrial Reference Frame, ITRF. Here is the irony. Due to these necessary, ultra-precise geocentric calculations, the IRM does not pass through the brass line at the Greenwich Observatory. The actual zero line used by satellites and modern industry is approximately 102 meters east of the famous brass strip. The physical marker that symbolized Britain's victory in 1884 is now technically in the west. Longitude minus 0 degrees 00 minutes 5.3 seconds. The monument to standardization is now itself a monument to error, proving that even the most fixed points are subject to the relentless hidden forces of geological and computational shift. The power of the system. This movement of the line symbolizes the ultimate victory of abstraction. The authority over the Prime Meridian is no longer vested in an astronomer looking through a telescope or a king signing a warrant. It is vested in an international consortium of computers and scientists who constantly calculate the Earth's precise center. The power to define the Prime Meridian now rests with this invisible system of systems. The conflict is over, but the control is absolute. This is the masterwork of the mundane we speak of. The most powerful structure in the world is the one you never see, the one that operates without human oversight, and the one that demands silent, universal compliance. The true lost art here is the loss of the national zero. Before 1884, every major civilization had the right to define where its world began. Paris, Lisbon, Rome, and Washington all offered beautiful, complex justifications for their own line, turning cartography into an act of cultural sovereignty. By accepting a single, invisible line that is calculated and corrected by global computer systems, we have surrendered this sovereignty entirely. The line is now purely utilitarian. It has no national flag, no philosophical beauty, and no connection to human experience beyond the numbers it feeds our machines. The Prime Meridian, therefore, is the most profound symbol of the 21st century's surrender. We exchange the right to define our own reality for the convenience of flawless global connection.
The true lost art of the Meridian Wars is the art of disagreement. For centuries, the existence of multiple national zero points represented a vibrant, intellectually competitive world. It affirmed that every culture had the right to define its own origin, its own center, and its own sovereign time. The Parisian line was a proud statement of Enlightenment rationalism. The Lisbon line, a memorial to the age of discovery. When the 22 nations voted for the utilitarian line of Greenwich, they did not just choose a line, they chose uniformity over individuality. They silenced the centuries-long debate, which was rich with geopolitical ambition, theological justification, and complex mathematics. They chose to solve the problem of chaos by removing the possibility of intellectual diversity. This choice had a direct deep impact on the ordinary person, particularly with the enforced imposition of standard time zones. Before 1884, time was a fluid, local condition. If you walked 2 miles east, your local solar time shifted slightly. Your life was anchored to the rhythm of the sun overhead. Farmers, villagers, and merchants operated by the reality of the sky. This was local mean time. The new system, forced by the requirements of international trade and, crucially, the railroad timetable, demanded that entire swaths of territory, often spanning thousands of square miles, adhere to a single arbitrary clock set by a line thousands of miles away. The moment the time zone system took effect, the public was forced to live by a time that they knew was physically false. When the sun was directly overhead in a town situated on the western edge of a time zone, the clock already read 1 p.m. The natural rhythm of the day, the solar noon that defined luncheon prayer, was officially severed from the mechanical time that governed the factory, the market, and the train. This was a profound act of cultural violence, the quietest revolution of the industrial age. It taught the world that the time that mattered was not the time dictated by nature, but the time required by industry. The system worked perfectly to prevent train collisions and synchronized telegraphs, but it came at the cost of an unconscious, vital link between human life and the natural rhythm of the planet. The masterwork of unquestioned authority. The Prime Meridian in its final form is a perfect, enduring metaphor for the invisible systems that govern modernity. It is a shared delusion. The line does not exist. It is a mathematical convention that is calculated and recalculated daily by computers that are themselves only accessible to a tiny international elite. Yet its authority is absolute. No one today questions the 0 point. No nation fights for the right to reset the clock to its capital. The line has become too functional, too central to global logistics to be debated. The convenience of a unified reality completely vanquished the need for an authentic, local one. This is the great lost art, the refusal to surrender. The refusal of the French to use the name Greenwich for 30 years, or the vote of Santo Domingo, are monuments to a time when a civilization would rather endure logistical chaos than concede the right to draw its own zero line. The Prime Meridian proves that the most powerful architectures in human history are not built of stone, but of unquestioned consensus.
The final judgment on the Prime Meridian is not about its geography. It is about its sociology. The victory of Greenwich over Paris was the victory of the utilitarian over the aesthetic, the triumph of industrial necessity over national identity. It established the principle that for global capitalism to function, the human element, the pride, the local rhythm, the philosophical debate must be excised. The Prime Meridian is, in the truest sense, a masterwork of the mundane. The most powerful, enduring architectural structures of the modern world are not the skyscrapers that pierce the clouds, but the invisible, abstract standards that allow the global system to function without question. These are the structures that are too boring, too technical, or too universally accepted to ever merit a second glance. The Prime Meridian, a line that is invisible and yet defines all space and time, is their perfect archetype. Consider the other unseen protocols that run our lives. The TCP/IP communications suite that governs the Internet. The ISO 9000 quality management standards that dictate the manufacturing of everything from a microchip to a car door.
or the gold standard and its abstract successors, which enforce trust in global currency. Like the Prime Meridian, these systems are not beautiful, they are not debated, and they possess the unchallenged authority of efficiency. The moment a system achieves this level of universal, unquestioned trust, it moves beyond mere utility and becomes a form of invisible, global control. The power does not lie in the line itself, but in the agreement to believe in the line. The conflict of the Prime Meridian was ultimately a crisis of trust. Navigators in the 17th century had to choose which map to trust. Governments in the 19th century had to choose which nation's time to trust. And the world settled on the system that offered the highest degree of reliability, regardless of its philosophical origin. The acceptance of the Greenwich line was the greatest act of collective trust in a single institution, the Royal Navy and the industrial complex it powered, that the modern world has ever seen. The loss of the national zero is the loss of our claim to define our own reality. The price of convenience is the surrender of sovereignty. The art that was lost was the fierce patriotic belief that one's own location, the center of one's own world, was the legitimate beginning of all measure. We have traded hundreds of unique cultural centers for a single, abstract computational point. This masterwork of the mundane is what allows a container ship loaded in Shenzhen to arrive precisely on time in Rotterdam, and what allows a financial transaction to occur across 3 continents in less than a second. It is the bedrock of the seamless, synchronized world. But it demands that we live in a reality that is manufactured, not experienced. A time dictated by a computer in a global network, rather than the sun above our heads. The final question for the Library of Lost Art is, now that the line is invisible, what else have we stopped seeing?
The 1884 resolution was the quietest death of cultural sovereignty in the history of globalization. The Prime Meridian is the artifact that memorializes our collective decision to trade the rich, messy, and fiercely debated reality of a locally defined world for the flawless, sterile efficiency of a globally synchronized one. The line runs straight, but the history that created it is anything but. The long conflict over the Prime Meridian proves that the true geography of power is measured not in miles, but in minutes. The victory of Greenwich was the victory of the utilitarian over the aesthetic, the final triumph of the standardized machine over the personalized human rhythm. We have traded the authentic solar time of our ancestors for the manufactured industrial time required by the global market. The line that does not exist, the invisible, shifting, calculated reference point that governs your phone and your flight path, is the perfect metaphor for the unseen rules that define modern life. Its power is derived entirely from the fact that we no longer question it. The final great masterwork of the mundane is a system so functional that it becomes invisible, thereby becoming unquestionable. The story of the Prime Meridian is the story of a lost art, the art of holding on to complexity. It is the story of hundreds of years when empires debated where the world truly began, each with its own beautiful, fierce, and mathematically justified conviction. We chose global coherence over historical complexity, and in doing so, we surrendered the right to draw the center of the map. The question is not where the zero line is, but what else we have unconsciously surrendered for the sake of efficiency. The Library of Lost Art is dedicated to restoring these lost narratives.
We investigate the cultural systems, the hidden aesthetics, and the forgotten methods that architecture our world, the ideas that were too dangerous or too inconvenient to preserve. If you believe that the most important history is the history we have forgotten, and if you seek the logic hidden in the ruins, consider subscribing. Join us as we continue to unearth the masterworks of the past. We will return with our next investigation shortly.